Okay, so I think, yeah, those were the three variants I wanted to discuss. Any questions you may have? I think there's already one question. Let me go through this. Okay. Question from Mohammed, but aren't gradient based on weights? dy dz to calculate dy over dx. But in residual case, the gradient is being added to say z, essentially making it the computations to dz. Shouldn't this cause wrong calculations? Yeah, I mean, I don't know if I get your question.
So what I'm
Um,
essentially saying is that since we are adding the gradients from, let's say, a very next layer to some previous layer, so we are not taking into account the weights in between. So when we compute the gradient, we actually like do something like, let's say, the derivative of that, like dz over dx to kind of like calculate the gradients. But here the gradients are being added to a previous layer, and we are not incorporating the weights that were like in between there, right? So the connections that we skipped. So how the gradient calculations will be true in that case in the residual
no,
neural network?
we are not adding gradients. We are adding activations here. So this x is activation, right? Again, fx is activation. And gradient will come from the top.
No, so
but
yeah, so when back propagating,
uh-huh.
so since like to compute the gradient, aren't we like, don't we do like d, for example, we want to calculate like if the y is output and x is the input and z is the middle like layer, then we compute it like dy over dz and then dz over dx to like propagate that, right?
That's true. That's true.
Yeah, so like when there is a skip connection from Z1 to, let's say, Z3, the Z2 will not be incorporated in that. So like when it will be back propagating, will it work? Like in
Why
that case,
it
I
won't
mean, of
be?
course,
It will be, right? So, okay, so let's start from the top, right? You will have some gradient here, and whatever gradient you have, it will flow towards this arrow and towards this arrow, right? Then
yeah.
whatever parameters you have in this layer, again, you will compute gradient, right?
Yes.
That can flow back to this direction. And again, you will compute gradient here. Then again, it will go back. So at this point, you will compute gradient, but that will depend on like all of these parameters, and you will get gradient from this location as well. So it's coming from both directions, right?
Okay. Yeah. So
So you
yeah,
will
I'm
have
not
this
sure.
kind of
Maybe I'm not
function.
clearly understanding it, but yeah, this, because like
Yeah.
since we are adding like a skip connection there, when back propagating, this skip connection gradient will all also be calculated and added to that. Is okay. Yeah, I think
Right.
it should work. Yeah, because like all these like libraries, I think they take care of like if you have like added something, then it would also be calculated the gradient of that.
Yeah, I understand like what you might be confusing at. So think about this. I mean, even after adding this skip connection, I mean, you have this function, right? So
Yeah.
whatever output value you have, let's say you have y over here. So y will be equal to this function.
Yeah.
And
Okay.
this
Yeah.
function is differentiable, right?
Yes. Yes. I think
This is
I
differentiable.
understand now. Yeah.
So as long as this is differentiable, you can just compute the gradient and okay.
Okay. Yeah. Thank you.
Good. So I think one more question from Teja. What are the best applications for DenseNet and GoogleNet? So initially, I mean, they were proposed for the image classification task, but since then, like, I mean, people have explored them for like a wide variety of different applications, right? So for example, you are seeing video segmentation for sure. Like, I mean, they will help in video segmentation. They will help you in action recognition or semantic segmentation, right? Wherever you need like to have your learning like scale invariant in all those scenarios, I think InceptionNet will be very, very useful. Okay.
Yep, understood it. Thank you.
All right. Any other question? So this, I think, was the last segment of this lecture. And next, we are going to do a quick overview of like it's a tutorial for PyTorch. Okay, so that was the first part, just the basics like how to define variables, how to use it for your networks. Now let's jump into, oh, we have a pop quiz actually. I think there's a question first. Let me go through that. Okay, so question from Anthony. So cost dot backward knows to write the values back to tensors W and B without taking them as parameters. Yeah, it knows. It has like all the information. It knows what your network is, what are like trainable parameters, what are non-trainable parameters. So it will make sure like to do all that update automatically. And that's why we need these frameworks so that we don't have to like perform those like required steps like in every time we have to develop our architecture, right? So that's the beauty, because that's the hard part, so that we can just focus on the easy part and create like different kind of architectures pretty easily. Okay, any other question? So I hope I answered that, Anthony. Any other question before we take the pop quiz?
In the tensor or the method, I'm sorry. If you go back a few slides, it said it's doing matrix multiplication. Is that the same type that we've been doing this whole time? I thought we were doing like element wise. Element wise different than, I guess I'm confused there. I thought matrix multiplication and element wise multiplication were different.
Yes, yeah, they are different.
Okay,
Element-wise multiplication is Hadamard product,
right.
and matrix multiplication is something different. So we covered these two, like I think in basics of linear algebra, right? So
Right.
you might be confusing because, so when you are doing filtering, right, the convolution operation, there you will have to perform element-wise multiplication.
Okay.
But if you remember, like from neural networks lecture, because this is like how to explain this? You have different weights for different neurons, right? When you're taking the linear combination. So for that, you will need matrix multiplication. Like if
Okay.
you-
Okay. I think I'm under.
Okay, good.
So convolution is using
Element-wise.
element wise.
Yes, that's correct.
Okay, and so this would do, so the sigmoid will handle like the element wise convolution, all that stuff behind the scenes. And what we're doing now is providing like the first initial weights. Am I understanding that right? And that's where you
Mhm,
can
yeah, that's correct.
matrix. Okay,
Yes.
all right. Thank you.
Okay, so let's quickly go through the book quiz. Okay, so this is about reshaping tensor, how we do that like using PyTorch tensors. The question is, you have a tensor which is randomly initialized, and the dimensions are like 1 cross 8 cross 32 cross 24, right? So this is a 4-dimensional vector or 4-dimensional matrix. And then I want to reshape this vector, or you can say reshape this matrix and store that in a different variable, which is y. So you know that we can use like tensor.view operation for that. So if I do this, the question is, what will be the shape of the resultant matrix y? So in this case, I mean, most of these dimensions are already given. And the question is, what will be the output of this print? So this is just printing the size. Okay. I'm opening this on web courses. Let me know if you can't see it. Let me put the. Okay, it should be available now. Let me know if you can't access it. So I think the time should already be up. And so if you remember, like when we are reshaping the size of the tensor, then one thing should be consistent, like a number of elements you have in this X matrix and the number of elements you have in Y matrix. I mean, that should not change because you're only changing the shape of the matrix. So the simple thing you can do is just compute like the number of elements you have in this matrix, which will be simply like 8 times 32 times 24. And then you can compute like the number of elements in this matrix, which will be 8 times 2 times this unknown, and then 3 times 8. So then you can just equate them, and I think that will give you the missing number. And one easy way to do that is like you can just start striking off these dimensions, right? So you can strike off 8 with this 8, so you don't have to worry about that. Again, you can maybe strike this 2 with this 32, which remains, which will like leave 16 over here. And again, that 16 you can cancel with 8. That will give you 2. And then you can cancel like this 24 by 3. That's going to again give you 8. So it gives you like 16 or something, right? Anyways, yeah, so that will be 16. Okay, so let's move on to, so any question in that? I hope all of you were able to do that. Okay, good. So let's move on
Can
to
you
the
again
next segment.
explain it? Sorry. Can you explain how you did it?
Okay, so you understood like the number of elements should not change, right? So you can just count the number of elements in this matrix, which will be 8 times 32 times 24. Okay, and again, you can count the number of elements here, 8 times 2 times 3 times 8, and then whatever this number is, you can use a variable for that, and then just equate those two. If you solve that equation, that will give you this number, right? Or you were asking of like the how to do it in a shortcut way? Sorry, I missed your question.
Yeah, about the shortcut.
Okay, so a simple way will be like you can cancel like these dimensions, right? Because at then you're going to equate these two. So if you cancel out 8 and 8, so you don't have to worry about this dimension. Then 1 means nothing, right? With multiplication. So you can cancel out 8 and 8. And okay, so 1 means nothing. You cancel out 8 with 8. You cancel out 2 with 32. And that will leave you with 16, right? And then you can cancel out. So again, -1, this is something we want to compute. 3, you can again cancel out with this, that will give you 8. And you can cancel out this 8 with this 8. So that leaves you with 16. So 16 should be this dimension.
Okay, thank you.
Is it clear?
Yeah.
Okay, great. Okay, so I think there's a question. Isn't more sensible to divide the size of the first array by the non-negative values and use the resulting number? Yeah, that's also true. I mean, you can use that. It's perfect. Okay, great. So let's move forward. We still have some time left. I think we'll not be able to cover like the whole segment. It's slightly bigger, but let me see how much we can cover in the next 10 minutes. Okay. Because otherwise it will be like somewhere we'll have to leave in between. Okay. So any questions you have until this point, I can take those. Otherwise we can end the lecture. Yes, Robinson, please go ahead. Okay, question from Robinson. Do we need to have functions in the programming assignment? That's a very good question. And I mean, ideally you should have, right? To be able to like write a modular code which can be understood by like others. Otherwise, you can write like a very complex piece of code without functions, just like on the top, right? But it's good to write functions. It's not just about like doing well in this programming assignment, but even like for a future as well, you should definitely do that. That's a very good practice. Okay. It's not that you will deduct like marks from your grades, but I will recommend you to write functions. And it's because of like the functions and definition of these classes, right? I'm able to like explain it to you how this works. Otherwise, there it could have been like done without the classes and functions, which would have been very complicated to understand. Okay, so that's like I think a very good example for you. All right. So any other question before we end it today? All right. So it seems no other question. Okay, question from I cannot see the pop quiz 4. It's available on web courses, right? Any other student who was not able to see pop quiz 4? Yeah, just write me an email, copy Binay the TA as well. We will look into it. I mean, it could be like when you try to submit, the deadline was over. Okay, but yeah, do write us an email and don't forget to copy Binay. Okay, we can look at for you. Okay, I think another question from Richard. Can you repeat the info on the programming assignment tutorial session with the TA? Yeah, so this will be like for your programming assignment 2, because that's like something new, and I assume like if you don't have experience with deep learning, that could be very challenging for you to understand. So we are going to do like this tutorial where we'll go through like each and every step of the question, so that you are able to like solve that problem easily. Okay, so it will be on Tuesday during TA office hours, 3 p.m. So next week. Any other information? Yeah, that I think that's the only information I had. So probably what you can do is, Richard, like if just in case I'm missing something, we'll share like this video, right? The recording. Just go through like the initial part of the lecture where I was discussing, just in case I'm missing any important point. Okay, all right. So let's end it here. I will still be here if you have any questions. Just write on chat. Otherwise, we can end it here. Thank you all. See you next week on Tuesday. Bye.